Today I solve this question reverse integer. Given a signed 32-bit integer x, return x with its digit reversed. If reversing x causes the value to go outside the signed 32-bit integer range of -2 power 31 and 2 power 31 minus 1, then return 0. So if the value is go outside this range, then we have to return 0. And let's see first example, x 1 2 3, and we should have to return the reverse of this integer 3 2 and 1. And same as in example number 2, the x is -1 2 and 3, so we should have to return -3 2 1. The reverse of this integer should be this. Similarly, the x is given 1 2 and 0, so 0 2 and 1 is same like 2 and 1. So let's see how I solve this question. Assume that we have given an integer array of 1 2 3, and we have to return the reverse of this integer array. It should be 3 2 and 1. How we would solve this question? Let's assume n is equal to, assume that n is equal to 1 2 and 3. Here we use the concept of modulus. It will give us the absolute value. And that m equal to, first we take the modulus of n, and modulus we take the n modulus with 10. So after it is 1 2 and 3. So we got the value of 3, and now take the n is equal to n by divided by 10. Now n is equal to 1 2 and 3. So after dividing by 10, we got the value of 12.3. First take the reverse integer value of integer value is 0. And by using this formula, we got our reverse value. Reverse less than reverse multiply by 10 plus m. So first our reverse value, initial reverse value is 0. Now after plus the value of m3, our modulus value of m3, we got the value of 3. Now after dividing n by 10, at this time our n value is 12 after roundabout. Now take the modulus of 12. Take the modulus of 12. After taking the modulus of 12, we got the value of 3. We got the value of 2. After dividing the n 1, 2, 3 by 2, 10. So at this time our n value is 12, and now take the modulus of 12. We got the value of 2. So value of 2. Now at this time our reverse value is 3. Now 3 multiply 10 plus m, and now our m value is 2, and we got the value of 32. And now we have value of 1, and 1 divided by value of 1 divided by 10, and we got the value of 0. Now take the modulus of 1. After taking the modulus of 1, we have value is 1, and now repeat the same process. Add the previous value 32, multiply 10, and plus the value of modulus 1. So after solving this, we gain our resulting value 3, 2 and 1, and it is our reverse integer value. Now this is the process we use in our code. Let's see code how it works. First we check the value of integer that they should give us. It should be range between this. The value of integer range is this. Extract the digit in one place x by using the modulus operator stored in digit. And then at the second step, add that digit to reverse as the rightmost in digit. Remove the one digit from the x and continue until x equal to 0. The same step we follow here that we previously understand by the example. First I should write the constraints, and if it overflow, then we return simply 0, and we use while loop to check if x is less not equal to 0. Then this loop is begun, and check this condition. If reverse greater than maximum integer, then divided by 10, reverse less than minimum integer divided by 10, and return 0. Digit x is our integer given array. Take the modulus. If x greater than 0, else x modulus minus 10, and here we use the same step of reverse, multiply 10 plus integer. But here I use the math.trunc x divided by 10. This is because in Python Modulus operator works slightly different than other languages such as Java or C. When it comes to negative number, basically you will get void result. If you try to do positive number and mod negative number, if you want the modulus to behave the same way with negative numbers as it does with positive numbers, but just have the result to be negative, then you need to make sure the divisor is also negative, since the modulus operation will always return a number with the same sign as the divisor. Lastly, I use the math.trunc instead of just using the float VN. Because of negative numbers, when dividing x by 10, or truncating the decimal, if the number is negative, then it would round down away from 0, when really we want to round up towards 0. And when you run this reverse value, oh my god.